At lesson 5.4. So moving on to have a look at Pythagoras' theorem, and this is the first part of that lesson. So the objectives today then, to be able to calculate the length of the hypotenuse in a right angled triangle and to solve problems using Pythagoras' theorem. So again, before we start, let's just check our prior knowledge. So you should be able to calculate square numbers. So I've given a few examples there of square numbers. You should be able to calculate the square root of any number. So again, a few examples there. You should know that squaring and square rooting are inverse operations and how to use them on your calculator. So on a normal Casio scientific calculator, we've got our square root button here and we've got our squared button here. So you should be familiar with those two buttons. And you should be able to identify the longest side on a right angled triangle. So remember, the longest side on any triangle is the side opposite the biggest angle. If we've got a right angled triangle, then this angle of 90 degrees in the corner has to be the biggest, because remember, all of the angles add to 180, so if one of them's 90, the other two combined have to add to 90 as well, so it must be less than 90 each. So if we know where our right angle is, then our longest side is opposite that. Okay, make sure you're happy with that before you move on. Okay, so identifying the hypotenuse then. So that longest side of a right angled triangle has a special name. It's called a hypotenuse. Okay, you will get used to hearing that name. We're going to be using that now through the next couple of lessons whilst we're looking at right angled triangles. So the key thing to remember then is that that longest side, the hypotenuse, is always opposite the right angle. So wherever you see a right angle symbol, the opposite side would always be the hypotenuse, even if the diagram doesn't look that accurate. Okay, so what is Pythagoras' theorem then? So Pythagoras' theorem states that the square formed on the hypotenuse of a right angled triangle, so there we go, we've got our hypotenuse, so we formed a square. Remember, to form a square, whatever length this diagonal line is, then this side must be the same to make this a square. So we formed a square here, and the square on that diagonal side, the hypotenuse, has the same area as the sum of the squares on the two shorter sides. So if we were to draw squares, again, on each of the two smaller sides, we added their areas together, we would get the same area as the one on the hypotenuse. So let's put some letters on there to make it a bit clearer then. So we're going to call the shortest side A, the next one B, and the longest side C. So if we find the area of the square then, this square C, remember, if this length is C, then this length must also be C. If it's a square, C times C is C squared. So the area of this square is C squared. We can do the same for A and B. So A times A means the area is A squared, and B times B means the area is B squared. And we said that if we add together the areas of the two smaller sides, then that's equal to the area of the square on the longest side. So Pythagoras' theorem is A squared plus B squared equals C squared, or you can write it the other way around, C squared equals A squared plus B squared if you like. Please make sure you make a note of that. That's the formula we're going to be using throughout these next couple of lessons. Okay, so we've stated that Pythagoras' theorem then is A squared plus B squared equals C squared. Well, why do we need to know this? So there are two things that Pythagoras' theorem is useful for. The first one is to find out the length of any missing sides in a right angled triangle given the lengths of the other two sides. So if they tell me the length of A and B, I could find C. If they tell me C and B, I could find A, etc. And also to check whether a triangle is right angled. So if we're given all three lengths, we can check if that triangle is actually a right angled triangle or not. Okay, we're going to start today then by having a look at finding the length of the hypotenuse. So we've got our triangle here. They've told us the shortest side is 5 centimetres, the next one is 12, and I can see that we need to find C. So C is always our hypotenuse, A and B the smaller sides. Now it doesn't matter which one you call A and which one you call B, as long as they are the shorter sides, but C is always the hypotenuse. So remember, there's our right angle, this must be our longest side, so that's the one we've labelled C. So all we need to do then is to put our values into Pythagoras' theorem. So Pythagoras' theorem, a squared plus b squared equals c squared. So we're going to put in our values. So a squared, a is now 5, b, our next side was 12, and 5 squared plus 12 squared equals 169. So c squared is equal to 169. Now remember, we just want the side C. This 169 is the area of the square on this side. So to find C, we do the inverse of squaring, which is square rooting. So we're going to square root the 169. That will tell us the value of C, and the square root of 169 is 13 centimetres. So the key bits there then, we square the two shorter sides and add them. We square root the answer, and that will tell us the length of the hypotenuse. Okay, you should notice if you forget to do your square rooting, because clearly if this side is 5 and this one's 12, then this one is definitely not going to be 169. So do just do a final check of your answer. Remember, side C has to be longer than 5 and 12, but it should be in proportion. It shouldn't be drastically different. All right, make sure you've made a note of that example before we move on to try some questions of your own. Okay, so you've got 3 triangles there. We can see they're right angled. They've got the little right angle in the corner, and we're being asked to calculate the length of the hypotenuse for each triangle, giving your answer correct to 2 significant figures. Pause the video and have a go at that now. Okay, let's have a look at the solutions then. So for the first one, we've got our 2 shorter sides, so 6 squared plus 7 squared was 85. We square root it to find the length of the hypotenuse, 9.2195. Remember, these dots tell me there are additional numbers in my calculator, so you've got to write down at least 4 decimal places before we do any rounding. That will stop us getting rounding errors later. And we're asked to give the answer to 2 significant figures, so the first 2 digits, checking whether we need to round or not, gives us 9.2 centimetres. The second one then, 4 squared plus 9 squared is 97, the square root of 97, 9.8488, and some additional figures to 2 significant figures, 9.8 centimetres. And the last one then, we've got 6.2 squared plus 5.1 squared, which is 64.45. If we square root that, we get 8.0280 and some additional figures. And again, to 2 significant figures, it's 8.0. And this one should say meters, so just excuse my typing error there. Okay, hopefully you're happy with those. If not, then you may need to go and have a little bit more practice, so you can go away and do that on Active Learn or BBC Bite Size. Okay, so our key point from this lesson then, in a right angle triangle, the longest side is called the hypotenuse, and Pythagoras' theorem states that in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares on the other 2 sides, and we write it as c squared equals a squared plus b squared, or a squared plus b squared equals c squared. Okay, let's have a look at the uses of Pythagoras then. So we're going to be using it to help us to solve some problems. So first we'll do a couple of examples. So a ship sails 300 kilometres due west. So there we are. I'm going to draw a diagram because that's going to help us to see what it is we're trying to find. So I've drawn a line pointing west 300 kilometres. It then travels 100 kilometres due south. So from where it ended up, we've now gone south 100 kilometres. At the end of this journey, how far is it from its starting position? So by travelling west and then south, we have travelled at 90 degrees. So that's really important that we know that these directions are at 90 degrees to each other. And we want to know from where we ended up to where we started, how far we have travelled. So that's our diagonal. So we can now see our two shorter sides and our hypotenuse there. So using Pythagoras then, 300 squared plus 100 squared is 100,000. Square root of 100,000 is 316.2277, etc. And we round that to a reasonable value. So I've gone with one decimal place here, 316.2 kilometres. Okay, our next one then. The foot of a ladder is placed 1.2 metres away from the base of a wall. So there's our distance from the wall to the end of the ladder, 1.2. And the top of the ladder reaches a vertical height, so vertical being straight up, of 3.5 metres. So again, our two lines have created a 90-degree angle. And we want to know how long the ladder is. So remember the base of the ladder there, there's the wall. The base is 1.2 metres away, the top of the ladder 3.5 metres high. We want to know the length of this ladder. So we're going to use our Pythagoras there. 1.2 squared plus 3.5 squared is 13.69. Square root, so don't forget we need square root to find our answer. And our answer this time is exactly 3.7 metres. Make sure you're happy with those examples before you move on. It is a really good idea to draw a sketch that will help you to see where your right angle is and where your longest side is. So pause the video, have a go at those two questions. Okay, let's talk through those then. So we've got a zip wire that runs from a vertical height of 20 metres, so there's our vertical height, and the total horizontal distance travelled is 40 metres, and we want to know the length of the zip wire. So we've got our 90 degrees between our vertical and our horizontal. There's our zip wire. So we're going to use Pythagoras. 20 squared plus 40 squared is 2,000. If we square root 2,000, we get 44.7213, etc. We were asked to give it to the nearest metre. So our nearest metre, we've got 44 here. A 7 means that our 4 is going to go up to a 5. We end up with 45 metres to the nearest metre. Our remote control cars set off from the same position. After a short time, one of them has travelled 20 metres due north, so north being upwards, and the other 15 due east. Now remember, they started from the same position, so they both started from the bottom there. How far are they apart? So north and east are at 90 degrees, and we want to know how far they are from each other now. So 20 squared plus 15 squared is 625. And if we square root 625, we get exactly 25 metres apart. Make sure you've marked your work and that you're happy with the answers you've got. Okay, so now we've got a challenge question. So a bit of a longer question with lots of things we need to think about. So Ron's dad says that Ron must not walk on the lawn. The lawn is a rectangle with sides of length 10 metres and 16 metres. When his dad is looking, Ron walks from his house to the gate by walking along two edges of the lawn. When his dad is not looking, Ron walks diagonally across the lawn. How much further does Ron have to walk to get from the house to the gate when his dad is looking? Give your answer correct to 2 decimal places. Pause the video, have a go yourselves before we check through the solution. Okay, so again, I'm going to start off with a diagram to make it easier. So there's the lawn. We were told it was a rectangle, and we were told that his house and his gate are at different sides because he has to walk along two edges to get from the house to the gate. One of them is 16 metres and one of them is 10 metres. So when his dad's looking, he walks from his house along one edge and then down the other edge. So in total, when his dad's looking, he's walked 26 metres. When his dad's not looking, he walks in a diagonal from his house to the gate. So we need to work out the length of that diagonal. So here we're going to use Pythagoras. So we've got our right-angled triangle because we know the corner of a rectangle is at 90 degrees. So 10 squared plus 16 squared is 356. The square root of 356 is 18.8679, etc. And I've just rounded that to 2 decimal places of 18.87 metres. Now we were asked how much further does he have to walk to get from the house to the gate when his dad is looking. So we need to find the difference between those two values. So 26 minus our 18.8679, etc. Again, I'm using at least 4 decimal places or the whole number that I've stored in my calculator. That gave me 7.1320, etc. And we've been asked to round that to 2 decimal places. So we've counted in 1, 2. The 2 means our 3 gets to stay a 3. So 7.13 metres. Okay, so now we've used Pythagoras then to help us find the length of the hypotenuse in a right-angled triangle. We're going to have a look at identifying some right-angled triangles using Pythagoras' theorem. So we're going to decide if a triangle is right-angled or not. So remember, if the sum of the squares on the 2 shorter sides is equal to the square on the longer side, the triangle has a right angle. So we've got a triangle with sides of 3 centimetres, 4 and 5. Now remember, A and B are the smaller sides and C is the longest side. So A and B are 3 and 4 and C is 5. So we put that into Pythagoras' theorem. 3 squared plus 4 squared equals 5 squared. Well, 3 squared is 9 and 4 squared is 16, 5 squared is 25, and 9 plus 16 is 25, and 25 is equal to 25. So yes, this one is a right-angled triangle. Let's have a look at another one. So this time we've got a triangle with sides 5, 8 and 10. Again, we've got to remember the 2 smaller numbers are A and B. The largest number is C. So we're going to put that into Pythagoras' theorem. 5 squared plus 8 squared equals 10 squared. Well, 5 squared is 25, 8 squared is 64, and 10 squared is 100. And if we do 25 plus the 64, 89 is not equal to 100. So no, it's not a right-angled triangle. If you're not familiar with this symbol, the equal sign with a line through simply means they are not equal to. So whenever you see a line through a normal mathematical symbol, it means the opposite. It means it's not that thing. Okay, make sure you're happy with those examples. So remember, we need to make sure we're using the 2 smallest values for A and B and the largest value we put in place of C. Okay, pause the video and have a go at working out if those are right-angled or not. Okay, so our first one then is not a right-angled triangle. The second one isn't either. The third one, yes, it is a right-angled triangle. D is also a right-angled triangle. And E is not a right-angled triangle. Okay, well, thank you for working through this lesson today. Next lesson, we're going to have a look at finding the shorter sides using Pythagoras when we're told the hypotenuse.